Welcome to my next video on strings. Let me title this first. Strings. Now, strings are used to store things in quotes. And the first thing I'll go over is concatenation. I know I already mentioned this in a earlier video, but I'll do it again. Let's say we had a string hello, and we're gonna add that to world. Right? These two are both in strings. What's kind of happening is, just pretend like they're a magnet. They're gonna get pushed together into hello world. Now notice that there isn't a space. And why there isn't a space is because we didn't put a space anywhere in these two words. This could be fixed by doing simply hello space plus world, or doing the opposite, hello plus world, or by doing this. You have hello, you're going to add that to just a space, then you're going to add that to world. And they'll each accomplish the same thing, which is hello space world. Now there is a method called the length method, and basically all it does is counts every single character in that string. So let's say we had Donald duck dot length. It'll give us a number which is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It also includes a white space. It does every single character, and it returns an integer value. So this is really useful when you don't know what the string is. Like, let's say you're doing user input, you don't know what the string, like perhaps their name, you don't know how long their name is going to be. So if you use the .length method, the .length method will calculate how many characters there are in their name in that case. Then substring. Substring is a very good method to use. It gets pieces of a string. Pieces of a string. There's two ways to use substring. But first, let's use a string. Let's say our string was Sparky the dog. Okay? And there's two substring methods that we can use. The first substring method is substring. And then to the substring, the parameter is going to be an integer. And let's say we're going to call it start index. Okay? So, for example, and let's say this was, I don't know, string s. Okay? So let's say we had s dot substring of 4. What's it going to print out? It's going to print out key the dog. How do we get key the dog? Well, indexes start at 0. For string, basically anything computer science, everything starts at 0. Obviously, if you're using the .length method, which counts the total amount of characters, you're not going to start at 0, right? But most of the time, if you want to count the length of something, the index of something, like the position of a certain character or element, it's going to be at 0. So this S is at 0. This P is at 1, 2, 3, 4, 5. The white space also gets counted. It's part of the string. 7, 8, 9, 10, 11, 12, 13. So we start at 4, and we print everything out for it too, which is key of the dog. Now we also have a substring the next one where it's int. I'm just gonna put int start and then int and exclusive, meaning your start index is going to be in the string, the new string, and the second part, the second index, is going to get counted in the string. So let's say we had s, well, I should do an arrows, s dot substring 4,12. What will it print out? Well, we start at 4 and we end at 12. But this 12 part is exclusive, so we don't count it. So it's going to be from 4 to actually 11. So you go up to 12, we'll take it down a notch. So it's going to be key the D. Key the D. Now, what if we had, let me give, I think 2 more examples would be nice. What if we had s dot substring, I don't know, 4, comma 14. So we go up to 4, we start at 4, and we go up to 14, but there is no 14. There's not a 14th index in Sparky the dog. It's fine. Why? Because we always go back an index, right? This is exclusive. So it starts from 4 and it actually goes up to 13, not 14, but 13, right? We take down one notch. So a key the dog gets printed out. So this is going to be key the dog. Let's see if I have enough space. I should have space. Now what if we had, so remember, if it's past the length of the string, but I mean, not if it's past the length of the string. If it goes up to the length of the string, then it'll still be like it'll still be part of the new string, right? The length of the string here is 14. How to know it's 14? Well, this is up to 13. This is the 13th index, which is the last index, and the first index is 0. So 1 plus 13 is 14. So that's how many characters there are. So we go up to the length of the string and you use substring. It can still work. Now this would be different if you had just s dot substring of 14. You set up 14, but there is no 14, and it'll give you an error. Now what if we had s dot substring of, I don't know, 4, comma 4. So we start at 4 and we end at 4, but we take it back one notch. Well, that's weird, right? Well, it actually gives us an empty string with a length of 0. And yeah, that's basically a substring. The next one is going to be just some other methods, which I won't go into detail with because the names of the methods take care of all the hard work for me. There is a to lowercase method, and if you didn't already, it turns all the letters lowercase. If the letter is already lowercase, it turns it, it stays lowercase. If the letter is uppercase, it'll turn lowercase. And if it's a number or a symbol, it'll stay that number or symbol. It just turns all the letters lowercase, okay? And the to uppercase method does the same thing, but obviously in reverse. It turns all the letters uppercase, okay? Now we're going to go over escape sequences. Now this is important. Sometimes, for example, you know how if you want to print a string, the quotations don't get printed? And let's say we do want the quotations to be printed. Well, how can we get those quotations to be printed? You use a thing called escape sequences. So basically with escape sequences, it allows things that can't normally be printed in a string to be printed, such as the quotes. So if you want to print quotes, for example, you would use a backslash. Now this backslash allows you to use the escape sequence. So this backslash means that you're going to use an escape sequence. The symbol right after it is what's going to be printed. So backslash quotes means that you're gonna print a quotation mark, right? Backslash apostrophe means you're gonna print an apostrophe. Now, what if you had a backslash? Well, that's just a backslash. Okay, this is a really tricky one. If you see two backslashes, it's only gonna print one backslash in a string. Backslash n means new line. You create a new line. Backslash t is tab. Backslash b is backspace. And backslash r is carriage return, which is basically the same thing as new line, creating new line. And these are, remember, these skip sequences, they're very easy to memorize. If you see a backslash, that's how you know you're going to use an escape sequence. So for example, let's say I had, I don't know. The world. Oops. Okay. So these two strings mean that these two quotation marks mean it's going to be a string, and then backslash quotes mean it's going to be a quote. Hello. Space world. But you see a backslash, and sorry if it doesn't look like a backslash, but it is. That means you're going to print one backslash. It's going to print our D. Backslash n means it's going to create a new line, right? And then it's going to print a quotation mark. And that's the string that gets printed out using escape sequences. Next, what I'll go over is the compare to method, which is a pretty simple method to use. You just need to know what an ASCII value is. So let me get this in the frame first. So ASCII values, these guys are associated with charts. So let's see why the character 0. The ASCII value for that is 48. Input value. So the character 0 has an ASCII value of 48, meaning the character 1 has a value of 49. The character 2 has an ASCII value of 50, and so forth, right? Now the ASCII value of capital A is 65. So the ASCII value of capital B is 66. The ASCII value of capital C is 67, and so forth. And now, lastly, the ASCII value of lowercase a is 97. So the ASCII value of lowercase b is 98. The ASCII value of lowercase c is 99, and so forth. So let's say again, just as a quick question, what's the ASCII value of the character 3? Well, 0 is 48. So 1 is 49, 2 is 50, 3 is 51. So the answer is 51. This is the ASCII value, okay? Now, when it comes to the compare to method, it lets you know if the letter precedes the other letter or not. So for example, let's say we had cat and lowercase cat. Well, I should have done it this way. Let's say we had string m equals cat and string n equals cat. Now they're the same words, but in Java they're actually two different words. Remember that. So let's say I wanted to print, remember this is not how you would print stuff in Java, but because I'm lazy, that's how I'm going to do it. M.compare to n. Okay? So we're going to have the string m and we're going to compare it to n. So what we're going to do is we're going to look at the first letters. This is capital C, this is lowercase c. Now how do you know which one goes first, capital letter or the lowercase letter? Well, because we're comparing m to n, it's going to be this letter minus that letter, or in other words, the ASCII values, capital C versus lowercase c. So if we know the capital value of A is 65, right? That means B 66 and C is 67. We know the lowercase value of A is 97, lowercase value of B is 98, lowercase value of C is 99. So we're going to do m compared to n, it's going to be capital C versus lowercase c. So 67 minus 99. So this is going to be 67 minus 99, which equals to negative 32. The negative sign means that the capital C comes before the lowercase c. And it makes sense because the capital letters are before the lowercase letters. So capital C precedes the lowercase c. Right? The negative sign tells us that the first word alphabetically precedes the second word. But notice that we have a 32. And why I'm saying 32 is because we just subtracted the same letter, but one was uppercase and one was lowercase. What if we had n dot compare to m? Same thing would be printed. It would be 99 minus 67, which equals 32. It's n, which is lowercase c, minus capital C, which is 99 minus 67, which equals 32. So if they're the same letter, but one's uppercase and one's lowercase, they're going to be 32 apart from each other. Now, if they were the same character, like literally the same character, they were both uppercase, then it would be 67 minus 67, which is 0. If it's 0, you keep on moving to the next letter until you get a number. If you don't get a number, that means they are equal to each other, and it'll give you a value of 0. And then this is the next method is the index of method, and it's a pretty neat method, but it has a lot of parameters. It's a lot of parameters. Let me put this here. Okay, this is the int index of method. Okay, this means the values can return, which is an int, and this is the method name, index of. So let's say we had the Dukes of Hazard. We're going to start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay? So to start off, what if we had, and let's call this string S. Okay? The first index the first parameter of index of that I'll talk about right now is just if you had a string. So let's say we wanted to find the first index of hazard. The way we accomplish this is we go from left to right. It's always from left to right, the index of method. From left to right. And it's the first instance of the string hazard. So the first instance of hazard occurs at 13. So the answer is going to be 13. And if I hadn't gone over this, these two forward slashes just means that it's going to be a comment. So the code doesn't get affected. Next index of method is if we had a string. So let's say we had hazard, but the next one is a number. What this number means is we're going to look for hazard starting at this index, which is 15. So we're going to start at index 15, which is right here, and we're going to look for the first instance from here, from left to right, for the word hazard. But here we see that there is no hazard, so it's going to actually print a value of -1. -1 is the default, like the default value. Or not the default value, but like if things go wrong, it'll print -1. Let's say it was, I don't know, of, or how about ard? If it was ard, comma 15, then it would print 17. You start at 15 and you go from left to right, so this way, right? And you look at the first instance of ard, which starts at 17. So the answer would be 17. Next, what if we had a character now instead of a string? X dot index of. You know it's a character if it just has apostrophes instead of quotation marks. So let's create a character. Let's say character D. So you're going to look for the first instance of the character capital D from left to right, right? Because it doesn't tell us where to start. So we're going to start at 0, and we're going to go from left to right for the first instance of capital letter D, which is 4. So the answer is going to be 4. Now if we had the same thing, right? Capital D. But now we're going to tell us where to start. So let's say we want to start at well, not D. How about E? Let's start at 4. So we'll put the character E starting at 4. So at 4, the first instance of the character E, which is 7. So the answer would be 7. Now what if we had this? S dot index of 68. Well, what the heck does that mean? Does that mean where we're going to start or what? No, it actually, what it means is this is the ASCII value. So if you see a really big number, it's going to look for the ASCII value. So let's read S dot index of 68. Well, I know that 65 is A, which means 66 is B, 67 is C, and 68 is D, or capital D. So we're going to look for the first instance of capital D. The first instance of capital D is at 4. So the answer is going to be 4. Let's say we had S dot index of 101, comma 4. Well, at lowercase a starts at 97, meaning B is 98, C is 99, D is 100, E is 101. So we're going to look for lowercase e, which starting at 4, the first instance of it is 7. So the answer is going to be 7. And that's it for index of. Index of is pretty easy. All it wants to do is see the index of, right? The index of whatever you want to know. If it's a particular string, where does it start? If it's a character, where is it placed in that string? And this is really neat. A really neat way of trying to pick up what you want to get, like let's say in your code or whatever. Now there's a thing called last index of. And it does the same thing, but instead of going from left to right, it goes from right to left. So if we had s dot last index of hazard, we start from right to left, it'll still be 13. But just remember that we're going from right to left, not from left to right. If we had, for example, s the last index of the character A, it would be 17. Why would it be 17? You start from right to left, and it's 17. If it was dot index of, it would be 14. Okay, and now there's other methods such as this method, char at, and then int index. So this char method returns a character, and this is the index we want to look at. So let's say we had s dot char at 7. The answer would be e, right? Because at index 7, it's lowercase e. And that's pretty much it. And then all these other strings and methods that I'm talking about are pretty self-explanatory, such as the replace method. String replace. Remember, this is what gets. This is the value of the data type, or this is the data type that's going to get returned, and this is what the method is called. So we're going to do string. I don't know. String old. String new. These are the parameters. So let's say we want to do s dot replace so replace let's do of with the. It's going to be, now the new thing is going to be the Dukes the hazard. The Dukes the hazard. You can also use this with characters too. S dot replace Z with L. And it's going to be the Dukes of Hallard. The Dukes of Hallard. This is all occurrences of whatever it's going to be. Every single one, okay? Don't forget that. Not just one time, but for every single occurrence. The next one is the trim method. So what the trim method does, I'm just going to use this back part. It just trims the beginning with, it removes white spaces at the beginning and end of the string. So there's a white space or a space in the beginning, string, space at the end, it's going to remove these and just get the string, okay? If we have, and then there's also Boolean contains method, which returns true or false. And this one's pretty self-explanatory. Does it, and it's going to be, or you should put like string s. Does it contain this string? So does this string, like, let's, for example, if we had this string, right, and we have this string, in this string, does it contain this? Yes or no? If it's yes, it returns true. If it's no, it returns false. And the last method for strings is Boolean starts with, which, if we didn't know already, does this string start with that string? So if we had Michael, does it start with the capital letter M? Yes, it does, so it's going to return true. right? And yeah, that's pretty much it. Basically, the method names, they're pretty self-explanatory. If you know what to do, if you just read the method name, you can pretty much get the answer right. That's how it is with computer science. Sometimes you don't know what you're doing, but the method names can help you out a lot, and you can get the right answer just by using your common sense in the test. This was strings. It's not everything strings, but just the main methods, um, because strings are a little bit kind of complicated, but they're really not. And these methods help a lot. And now you can use these methods to make your own little programs. And I'm actually thinking of doing videos where I tell you, okay, I'm gonna give you the question of the program, you try and do it, and then I'll give you the answer to that program. And there's always more than one answer. Some answers are just more efficient than others. Yep, that's the end of this video.